here we have an iPad 4, an old ancient iPad 4 that came in for no power. You may ask, why is the customer mailing over an old iPad 4? I don't know. You should ask the customer. Maybe the customer wants information, maybe he wants data, maybe it's important to him, sentimental value, I don't know. We're gonna be charging the customer the rate that we charge, regardless if that tablet is 50 years old or 1 year old. So let's take a look. We already have the board out, as you can see, right here. And that's the charging port. We did try another charging port just to eliminate the fact that the problem could be the charging port. And we replaced the battery, but the tablet is charging at a constant 0.4 amps. So we know that we have a problem on the board. Usually when I'm working with any iPad, if we have a constant 0.6 amps or 0.5 amps or even 0.4, that's an indication that we may have a short circuit on the board. So this one is doing the same thing. It's constantly charging at 0.4 amps. And how do I know that 0.4 amps is a short? After a while, you start to develop a pattern. There's no one place to go online that tells you 0.4 amps means a short circuit, or 0.5 amps means that, or 0.8 amps means that. It's all based on experience. After a while, you develop a pattern on what that number means. 0.4, I think it should be an indication of a short circuit. I plugged in the charging Flux right here, and we're gonna plug the charging cable. You know what, before I do that, let me grab my thermal camera. Big Boss has it. Right now, the first thing I wanna do is plug the charging cable before we look under a thermal camera. And we're gonna see the amperage being drawn by this tablet. The cable is plugged in. And let me remove my phone from the wireless charge on top. Right now, the tablet is drawing 0.2 amps and I do not have a battery connected. If you do not have a battery connected, the board should not be drawing any amps. But right now we see 0.2 amps being drawn by the motherboard at 5 volts, right there. So something is drawing amps. Something is heating up on the board, consuming those amps. Let's take a look under a thermal camera while the board is plugged in and see if we can tell where heat is coming from. And I do see heat right here. So heat is coming from the corner right here, and we have a chip here. Which chip is that? Let's take a look. Switch over to the microscope, and that's the chip that is getting hot. Which one is this? 338S1116. That's an audio IC. That's the same audio IC used in iPhone 5s. And right now we do not know if that IC is good or not, but heat is coming from this IC. It could be something else causing this chip to heat up. It does not have to be that chip that is bad. And that's probably underfill because the chip is protected, and probably some underfill spilled here. Or it could be that a capacitor shorted out one of those caps, or maybe something under this frame here. A lot of possibilities. Meter in diode mode. And we do not have a short anywhere. And we do not have a short. None of those capacitors are shorting to ground. But what's under here? And I'm using this fine precision shears. You can find it on our e-commerce site. Just search for shears, S-H-E-A-R-S. What's under here? Nothing. So right now I have a strong reason to believe that maybe the problem is the audio IC. All right, let's desolder that audio IC. We're gonna remove it, and the audio IC is protected by underfill, so we're gonna have to scrape off the underfill to properly remove the IC. And we're gonna also have to cover the plastic connectors so we do not end up burning them. Removing this audio IC is not like any other normal IC removal. We have to carefully scrape off that underfill from the edges to be able to lift up and remove that IC. So let's start. Because the underfill is making a connection with the components nearby. If we try to lift this chip up by applying heat and we do not break off this underfill, what's going to happen is all those components are going to pull off with the chip. So we have to break the connection between those components and the chip. And we do this by applying heat to a point where we are able to break this underfill of the edges. And look at how we have plastic connectors on the bottom. I'm pointing heat over here and not here, but maybe it's safer if we can cover those connectors like this. Break it off. And just like that. And we're gonna have to break the underfill from here as well. Just enough heat to break that underfill. What is the right heat? It depends on the board that you are working with. Maybe start with 190 degrees Celsius or 150 degrees and see how it goes. If the underfill is hard, I've seen underfills on, for example, the iPad 5. If you try to remove the TriStar chip, it's a nightmare because the underfill is hard. And some underfills, soft. Okay. And now if we increase the temperature, and let's try to desolder that chip. And just like that. You see all that underfill? I just want to make sure no two solder balls are touching so we can test to see if the problem is fixed. If fixed, great. We're going to order an audio IC. We do not have that IC in stock because it's not a usual repair that we do. On iPads, audio ICs are not a popular fault. And we're going to get rid of the glare. And people are asking, when are you going to post that video on how to remove a glare? I'm thinking in about 3 to 4 weeks. The tool that is used to get rid of the glare that I use will be here in 3 to 4 weeks, so I will demonstrate how it works and what I do to remove that glare. There are a lot of ways to remove glare, but the technique that I use, I would say, is next to none. And no, it's not a polarizer. I've used polarizers in the past, and the disadvantage of using a polarizer is it makes the image dim. It cuts off a lot of light to a point where you cannot see very well. Fume extractor on, and we're gonna have to add more flux. Right now, all I want to do is just make sure no two solder balls are touching, so we can test. Maybe the problem is not the audio IC, who knows? That's not a common fault I worked on before, but there's a first for everything. Right, for the most part, we should be good. I do not see anything touching. Let's quickly clean up. And now we're gonna test. We're gonna test and see if we were right about this audio IC. Charging connector plugged in. Yes. I have the cable plugged in. I think we fixed the problem. I have the cable plugged in right here, the charging cable, and the charging station is actually going on and off, charging 0.1 amp or not charging at all, which is normal because we do not have a battery connected. Let's check the board under a thermal camera and see if we still have heat on that audio IC area, and then we're gonna try it. So let's go under the thermal camera again and look at this. We no longer have heat on the audio IC area right here where my finger is. Great. We're gonna reassemble the board and we'll see if the tablet will charge and power on. If yes, great. We can then order the IC, the audio IC, solder it back on, and we're all good. So let's see. Let's check up on Big Boss. Did it work? Not yet. Will it charge? Yes, 2.4 is good. And anything on the screen? Yes, battery logo. We're good. We're good. The tablet is now charging at 2.4 amps. And we do see the battery logo. The battery is dead. And we're good. We're gonna have to wait a couple of minutes before the battery charges. But the charging rate is excellent. Before it was showing a constant 0.4 amps. Very nice. That's it. The job is done. And like always, Big Boss is the boss of all bosses. Always. We're gonna have to order an IC for the customer, replace it, and send it back to him. I hope you enjoyed this video. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.